Okay, quiet please. We're going. Yep, I'm trying. Okay, so today we're doing the multiplying. So we did adding, subtracting, and today we're doing multiplying. What do you think we're doing next class? Wrong. We do distributive property, and then you do dividing. So the sign of a product. Remember, what does the word product mean? It's the result of multiplication. Okay, a positive number times a positive number is a positive number. A negative number times a negative number is a positive number. And a positive times a negative is a negative. Okay? So you got to keep the signs correct. Yeah. How do two negatives equal a positive? Okay? Good question. Good question. So let's say I was going to do 2 times negative 3, right? 2 times negative 3. What does that really mean? That means negative 3 plus negative 3, correct? So on a number line, that would be 0, 1, 2, 3. There's negative 3. So I would start at negative 3, and then which direction would I go? I would go to the left, right? So I would get to negative 6. That's 2 times negative 3. Okay, what does it mean when you put a negative in front of something? What kind of number do we call that when you put the negative symbol in front of it? It's the opposite, right? So by putting the negative right there, we're saying the answer is not going to be this negative 6. It's actually going to be the opposite of negative 6, which is 6. I mean, that's the way I think of it. Why negatives times negatives make positives. Because we know clearly when you multiply a positive times a negative, that keeps pushing you further in the direction of negative numbers. And then that last symbol there, that's basically saying, okay, now take the opposite of it. That's why it works that way. Okay. So is this one going to be positive or negative? Negative. So what is 3 times 6? Negative 18, right? Okay, a negative times a negative times a negative. What's the sign going to be? Negative. Okay, because 2 of them multiply together to give you, let's say we multiply these 2 together, we get a positive 12. So we still have to multiply with one more negative. Negative 6. How do you multiply a fraction times 12? Yeah, basically you do just divide it by 2. Or you could do this, which I'm sure you've seen before. You could say, well, this 2 is in the denominator, right? It goes into 2 once. And how many times does 2 go into 12? 6. So the answer is the negative 6. Okay, you try that one. I'll give you 5 seconds. Okay, what'd you get? Positive 14, right? Okay, try that one. Good. How do you multiply 3 numbers together? Yeah. First you got to multiply 2. Which 2 do you think you'd probably want to multiply first? Yeah, I mean, you could do anything you want, right? I would probably do the negative 4 times negative 9 first, but you don't have to. So what's negative 4 times negative 9? Positive 36, right? So now, how do you multiply? Let's do it in decimal form, right? How do I multiply 0.5 times 36? How does that operation work? No, I want to multiply here, right? In this form, right, I go 5 times 6 is 30. 5 times 3 is 15. Plus 3 is 18. Now, the next number is 0. We don't have to multiply by that. And then where do I put the decimal point? Yeah, since the 0.5 was over 1, we need to go over 1 to make our decimal point. So it's 18. Now, the sign of it should be negative because it was actually a negative 0.5. Yeah. You could just say negative 18. Okay, try that one. John, did you get it? What'd you get? Negative 28. How many got negative 28? Only 2? Negative 28 is right. So, John, how did you do it?
Wow, I multiplied 7 times 3 negative first.
Okay, quiet, please. John's talking.
Then I multiplied 21 times 4 over 3. I turned 21 into a fraction and made it 21 over 1. Then I figured out how many times 3 would get in the 21, which is 7. So 3 turns into 1, and 21 turns into 7. And 7 times 4 equals 28, and it's over 1, so that would make it negative 28.
Perfect. Okay. But what he multiplied the negative 3 times 7. No problem with that. What else could you have done? Adam.
You could have turned 4 over 3 into an improper fraction.
No, not quite what I'm looking for. What you could have done is, like before doing the multiply, why not just cancel? This 3 cancels with that 3. Since one's in the denominator and one's in the numerator, and now you don't even have to deal with the 3. Now you're just multiplying 4 times 7, and you got that one negative sign left over. Okay. So now we have properties of multiplication just like we have properties of addition. In fact, they're considered to be properties of real numbers. That's what they are. And we have the same commutative. Commutative means what? Changing the order doesn't matter. Associative means the grouping symbols don't matter. Identity, we had an identity property for addition, right? Which is if you add 0 to a number, you get the same thing. What do you multiply times a number to get the same thing? 1, right? And then we have, now here's one that's different. The property of 0 for multiplication. What is 0 times anything? 0, right? Anything times 0 is 0. And also the property of negative 1. What happens when you multiply a number by a negative 1? It flips the sign, right? So if you ever need to, we will, when we're solving equations in the next unit, and you got like a negative x and you need to turn it into a positive x, then you're going to multiply by negative 1 because that'll flip the sign. So those are all the properties for multiplication. So let's see if we could recognize some of these. What property does the first one look like? Okay, that looks like, what changed from the left side to the right side? The grouping symbols, and that one is associative. Okay, what about the next one? 8, 0 property, good. How about the next one? What did they change? The order. Okay, the next one. They multiplied a 9 by -1. Not the inverse, the multiplication property of -1. It flipped the sign. And then the last one is 1 times V equals V. So that is identity property. Okay, properties. Okay, so then we do this. Let's find the product and justify steps. I mean, this is how this works, just to give you an idea. And you know, they have these kind of questions on the SOL where they have like an simplifying some order of operations or something, and you got to like say what's going on between all these steps. So in this one, the first thing they did is like this. They said, okay, how about if I make this -4? -4 times x times 0.25. What did I just change? The grouping. So what property is that? Associative, right? Okay, now I'm going to -4 times 0.25 times x. What did I just change? The order, right? And that property is commutative. Okay, now I'm going to regroup. What did I just change? So it's another associative. And then finally, what is -4 times 0.25? Yeah, if you multiply by 0.25, right? 4 times 5 is 20, 4 times 2 is 8, plus 2 is 10. And the decimal point moves over 1, 2. So that's actually 1x. Okay, so I'm not sure if they gave that a property. Sometimes they'll call that, no, that one's not identity. It could be inverse, kind of. I mean, because you're really multiplying 4 times 1/4. But I'm going to leave that one alone. Okay, and then the last step we could say is -x. What makes -1x equal to -x? Identity. That's identity. Yeah. Yeah. When they multiply like that, honestly, quiet please. When they multiply and just like put what it equals, usually they call that substitution. And so it might be some. What's that? Yeah, when you just do the math, that's substitution. Okay, so you try one of those. And try to multiply that and see what you get, and do your best to try to justify steps that you're using. So what did anybody do to try to simplify this? Yeah, go ahead.
Me?
Yes, go ahead.
Oh, I just changed from 8 into a fraction in -1. I just put over 1.
Okay, and you made that negative. Okay, so you still got to have -x, and then you called this -1/1, like that. And then what do you do?
Well, I haven't changed negative 0.8 into 4/5. I just put it as 8/10.
Is 8/10? Okay. Well, yeah, the simplified fraction would be 4/5, but that's okay. 8/10. Okay, you did that, and then what'd you do?
I multiplied 8/10 by 1/1.
Okay, And what do you get when you did that?
-8/10.
What property would that be? That you multiplied 8/10 by -1 and got -8/10. That's a property. Adam? No? Remember? It's the multiplication property of -1. There you go. So you still had the x there to deal with, right? So now you still have to multiply that by -x. Okay? And then what'd you get when you did that? Okay. I mean well, that's not quite right, is it? What's wrong with that? It's positive because it's a negative times a negative. You know, I would say in this right here, they're multiplying all of this by -1, right? So you could easily just as a first step say, okay, well then that just means that I could rewrite it right away like 0.8 times x as a positive and multiplication property of -1. And that's really all you can do. That's the answer. That's not really a good example of how you get asked to do properties on the SOL. Okay, let's see this one. In 1900, the elevation of Mono Lake in California was about 6,416 feet. From 1900 to 1950, the average rate of change in elevation was minus 0.12 feet per year. Okay, from 1950 to 2000, the rate of change was about negative 0.526 feet per year. So how much did it lose from 1900 to 2000? Well, how do you figure out if it's losing negative 0.12 from 1900 to 1950? How do we figure out the total change in those 50 years? Yeah. Yeah, it was 50 years, and it was going down by negative 0.12 per year. Okay, then what did it do for the next 50 years? It went down to negative 0.526. Okay, so that's what we have to calculate. Right? How do I multiply 550 times 0.12? What's the math? What do you do with that 0 since it's in the ones place? Don't you bring that straight down? It's going to be a 0. Okay, then we multiply times 5. 5 times 2 is 10. Carry the 1. 5 times 1 is 5 plus 1 is 6. Okay, now the 0.12 had the decimal over 1, 2. So we got to go over 1, 2. That's 6. Right? It's gone down 6 feet in the first 50 years. Now we got to do the other. 50 times 0.526. Be a little bit more. Bring down the 0. 5 times 6 is 30. 5 times 2 is 10. Plus 3 is 13. 5 times 5 is 25. 26. Okay, and how many decimal points do I move over? 3. 1, 2, 3. So it's actually 26.3. So it went minus 6 in the first 50 years, and then it dropped 26.3 in the next 50 years. So what's that total? How much did it drop in 100 years? Minus 32.3. Okay. That's it. So we will have another quiz on Friday. Test is next Tuesday, which is October 4th. We're almost done with September. That's a homework?